Hello everyone. In this video, we're going to review how to make and display cross sections in the .map file. In our previous video, we did this in the petrophysical interpretation file here. So we came in, we made an automatically generated cross section, and we displayed our well logs. We reviewed how to pick tops and change our templates and flatten and things like that. We are going to review some of that in this video, but we're also going to review how to do this inside of a new file type. Now, before we set off on doing that, there is one thing that we need to do. We need to make ourselves a well list of the wells that have logs available. So what we're going to do is we're going to right click, we're going to say select polygon, and then we can just left click, and when we're done, we can double click to end, and that will draw a polygon. We can right click in that polygon and we can say save APIs to points file, and we're going to name this wells with logs, and we'll hit OK. And the reason that we're doing this will become a bit obvious as we move into the map window. All right, so now that we've done that, we've now got our new wells with logs filter here. We're going to right click on our welcome project folder, and we're going to say new map, and I'm going to call this just welcome project .map. Say OK, and this generates for us a new map window. So to get started here, I'm going to click on the plus icon here in the top right. And we'll be showing you how to add a number of things to the map view in subsequent videos, but I'm going to start off here by adding our well markers. So I'm just going to say layer type is well markers, and I'm going to select our well headers. And I'm going to click add. And you'll notice a number of wells appear here. And what you'll notice is that we've actually got around 7,000 wells here in that demo data set. Now that is significantly more wells than we have logs for, and it would make it very difficult for us to identify the wells that we want to use for our cross section. So this is where that well filter that we just made comes in. So I'm going to click on the pencil icon here beside our well database, and I'm going to say specify well set, and I'm going to choose the wells with logs, and I'm going to click apply here. And now we're down to, it hides away the other wells, and we're down to the wells that have logs. Okay, so now that we can see those, let's say we want to make a cross-section layer here in our map. So there are two things that we need to do. First, we need to click here, and we're going to say, hey, let's make a new cross-section layer. And we'll need to, once again, choose our wells, and we'll need to choose our logs as well. Now, in our previous video, we had already picked a few cross sections. So we're going to do the same. We're going to choose our cross section points here, and we are going to just type in here welcome project, and it'll filter down to our cross sections for us. And we're going to tell it to show all lines, and we're going to say add. And now we can see our cross section lines from our previous work here. Now we've got the lines. Now that may be all that you want for display purposes, but you probably want to see the cross section as well. So to do that, I'm going to click here, and I'm going to say split window. And now I'm going to click once again on this menu. I'm going to say add tab, and we're going to add a cross section view. Now, once I've done this, you'll see that it's automatically populated my well database and my log database. What I will also want to do here is I'll choose my tops. If I had deviations or raster files that I was bringing in, I would add those here as well. And now this is very similar to what we had in the petrophysics. Once again, we have our cross section here, our list of wells. We have the same controls to come in and flatten. We can still zoom in and out. We can change the templates. And we can pick tops. So for example, here I can see I'm missing a couple of these lower Parkman tops. So I can just come here and right click and say capture, and I can continue with picking my tops in these wells. So there we go. Now we've picked that lower Parkman top across the area. Once I'm done, I can say cancel capture. Much like in the previous video, we can also create a new cross section. So I'm going to create east-west 2. So you'll notice it gives us this blank window again. And I'm just going to right click and I'm going to say capture east-west 2. And I am going to just click here across my wells. And once I'm done, I'll say cancel capture. And we see that it has drawn our cross section here. And once again, we see a couple of wells are missing that lower Parkman top. So once again, we'll just right click and say capture. And we can add that top into our interpretation. So it's easy as that. So you may wonder, why is it would I do this in a map window as opposed to the petrophysics window or vice versa? There are a few reasons here. So within the petrophysics, so we're going to move back to our welcome project CPI here. And you'll notice here in the plot template option, we have a number of templates that are available. And these templates are all focused on part of the petrophysical interpretation. So we would do it in the CPI if we wanted to, let's say, make comparisons of our unnormalized to our normalized gamma ray, or our repaired density to our unrepaired density. Or if we wanted to look at our saturations or clay volumes or things of that nature. So that's a good justification for doing it in the petrophysical interpretation. It helps you QC that interpretation as you move along. Now, in the map window, this does offer us a few advantages. The first advantage here is that we can give ourselves some more reference here on the map. So, for example, I can come here and I can add my counties. So let's say I wanted to know where I was at a little bit better. I could display my county shapefile. And I could add, let's say, another shapefile for my townships here. And now I have, more available to kind of help me reference where I'm at. So that's one reason. The other thing that we can do, and I'm going to remove those layers here. The other thing that I can do is I can actually have multiple cross-section windows open at once. So once again, I can come here, click on this menu, and I can say split window. And this splits the window, and I'm going to drag it down to here. And now I've got my cross section up here, and I can say add tab, and I can add another cross section view. Once again, I can go back to, I can select which layer I want to show. So I'm showing layer 1 here and another layer here. So if I had multiple cross section layers, let's say I had a regular grid of cross sections and an irregular grid, I could choose those. But I can also come here, and so here I'm looking at my east-west 2. I could come, so we have these synced up. So, if we wanted to look at, different parts of the same cross section here, we could look at that. Now I'm going to say layer 2 here. And what I'm going to do is I will now, and I'm going to come and I'm going to choose those same databases here, and this will allow us to do something quite useful, which is we can now look at, let's say, our east-west cross section up here, and we can look at our north-south cross-section down here. And so this gives us a way to understand how we are, how we're tying our loops here with respect to picking our tops. Are we picking it one way in our north-south and another way east-west? So this is a quite useful feature for when you're doing geological correlation. And once again, the way we do that is we added this window. We told it that we were going to use our second cross-section layer, and that automatically created it here in this window. And then we just went to the settings for that, and we selected our well database, log database, and our points. All right, so now we know how to make cross sections, pick our tops, and we can do this in both the petrophysical interpretation and in the map views. All right, in our next videos, we are going to focus on generating structure and isopack maps.